Welcome to this video on application security testing. This guide covers everything from SAST and DAST to professional penetration testing, helping you find and fix vulnerabilities before hackers do. In this video, we will explore the essentials of application security. We cover core concepts like SAST and DAST, the OWASP Top 10, hands-on tools, and how to integrate security into your CI/CD pipelines for a robust development lifecycle. What is application security testing? It is the practice of identifying security flaws in software throughout the development lifecycle. By combining automated tools with manual testing, we can prevent attackers from exploiting vulnerabilities like SQL injection or broken authentication. Application security testing is crucial. Applications are a primary target for data breaches, and fixing security issues early in development is significantly more cost-effective than patching them in production. Compliance regulations also mandate these practices to protect sensitive data. The numbers speak for themselves. With 43% of data breaches involving web application vulnerabilities, and the cost of fixing bugs in production being 30 times higher, robust testing is not optional. It is a necessity for every modern organization. We categorize testing into four main types: SAST for static code analysis, DAST for dynamic runtime testing, and IAST or RASP, which provide interactive analysis and runtime protection respectively. SAST, or Static Application Security Testing, scans your source code for flaws without executing the program. It integrates directly into developer IDEs and CI/CD pipelines, making it an excellent way to catch vulnerabilities early, though it can have a high false positive rate. The SAST process follows several key steps: ingesting the code, building an abstract syntax tree, analyzing data and control flows, and performing taint analysis to track untrusted inputs, ultimately resulting in a list of potential vulnerabilities for developer review. Some of the top SAST tools include SonarQube, which is great for its broad language support and integration, Semgrep, known for its speed and customizable rules, and enterprise platforms like Checkmarx and Veracode for comprehensive security coverage. To summarize SAST, its main advantages are early detection and integration into the developer workflow. However, it is limited by its inability to detect runtime issues and the potential for high false positives in its reports. Next is DAST, or Dynamic Application Security Testing. Unlike SAST, DAST tests your running application from the outside, just like an attacker would. This allows it to identify runtime issues and misconfigurations that static analysis might miss. The DAST process involves crawling the application to map its structure and then fuzzing inputs with various payloads. It analyzes HTTP responses to find exploitable vulnerabilities, compiling these findings into actionable reports with proof of concept evidence. Industry standard DAST tools include Burp Suite Professional, which is highly popular for manual testing, OWASP ZAP for a powerful, open-source alternative, and Nuclei, which is excellent for rapid, template-based scanning of various endpoints. DAST provides a clear view of exploitable vulnerabilities in a running system. However, it requires a live application, can be time-consuming, and cannot pinpoint the exact line of vulnerable code, making it best suited for staging environments. When comparing SAST and DAST, remember, SAST is for your code during development, while DAST is for your application at runtime. Using them together gives you the best protection, covering both structural flaws and operational vulnerabilities. Moving on to IAST, or Interactive Application Security Testing. This approach uses instrumentation agents embedded directly within the application runtime to monitor data flows and security, combining the best aspects of SAST and DAST in one. RASP takes security a step further by operating inside the production application. It monitors requests in real time, allowing it to block attacks, terminate malicious sessions, and provide immediate protection as a last line of defense. Software Composition Analysis, or SCA, is essential for modern development. Since applications are largely built on open-source dependencies, SCA scans these libraries to find known vulnerabilities and ensure your software supply chain is secure. To understand the threat landscape, refer to the OWASP Top 10. This industry standard list highlights the most critical web security risks, from broken access control and injection flaws to insecure design and cryptographic failures. SQL injection remains a dangerous vulnerability. It occurs when untrusted user input is directly inserted into database queries. The best defense is to always use parameterized queries, which treat user input strictly as data, not executable code. Cross-site scripting, or XSS, happens when malicious JavaScript is injected into web pages. Whether reflected, stored, or DOM-based, it can steal session cookies or manipulate content. Prevention relies on proper output encoding and sanitization. Broken access control is currently the top web security risk. It happens when users perform actions they aren't authorized to do, such as accessing other users' data via IDOR or escalating privileges. Always enforce authorization checks on the server. SSRF, or server-side request forgery, tricks your server into making unintended requests to internal resources. This can expose sensitive cloud metadata or internal services. Protect your infrastructure by whitelisting URLs and blocking access to private IP ranges. CSRF, or cross-site request forgery, exploits browser trust. It tricks an authenticated user into performing unintended actions, like changing account settings or transferring funds. Using anti-CSRF tokens and the same site cookie attribute provides effective defense. Authentication and session management flaws involve weak passwords and insecure token handling. Prevent these by enforcing strong password policies, using multi-factor authentication, and ensuring session tokens are both random and properly expired. Security misconfiguration often exposes systems unnecessarily. This includes default credentials, verbose error messages, or open cloud storage buckets. Regular configuration audits and adhering to security hardening baselines are vital to minimizing your attack surface. For penetration testing, Burp Suite Professional is the industry standard. Its intercepting proxy, automated scanner, and tools like Intruder and Repeater allow security professionals to thoroughly test applications and uncover complex vulnerabilities. OWASP ZAP is an excellent, free, and open-source alternative for automated scanning. It features a robust spider, a fuzzer for testing inputs, and can be integrated directly into CI/CD pipelines for continuous security testing. Nuclei is highly regarded for its speed and template-based approach. By using simple YAML templates, security teams can rapidly scan for a wide variety of vulnerabilities, making it a favorite for bug hunters and fast-paced development teams. Finally, a web application firewall, or WAF, acts as a primary defense, filtering traffic to block common web attacks. While it is a valuable layer of security, remember it is not a replacement for fixing vulnerabilities in your actual code. APIs are now the fastest-growing attack surface, with most modern web traffic moving through them. Securing REST, GraphQL, and microservices is critical, focusing on issues like broken object-level authorization, mass assignment, excessive data exposure, and proper rate limiting. GraphQL introduces unique security challenges. Attackers can exploit introspection to map your schema, use nested queries for denial of service, or perform batch attacks. Always disable introspection in production and enforce query depth limits and per-field authorization to stay protected. Mobile security requires looking beyond the web. We test for insecure local data storage, binary reverse engineering, and bypasses for certificate pinning or root detection. Use tools like MobSF and Frida to analyze Android and iOS applications effectively. The OWASP Mobile Top 10 highlights critical risks such as improper credential usage, supply chain vulnerabilities from third-party SDKs, insecure communication, and insufficient binary protection. Addressing these ensures your mobile apps remain resilient against common exploitation techniques. Professional penetration testing follows a structured methodology: reconnaissance, mapping, discovery, exploitation, post-exploitation, and reporting. Always ensure you have written authorization before testing. Unauthorized activity is illegal in most jurisdictions. Phase 1 is reconnaissance. By using passive techniques like WHOIS lookups, DNS enumeration, and dorking, you can gather valuable intelligence. Tools like Shodan, Census, and GitHub Search help identify exposed services and accidentally leaked credentials. Automated scanners are powerful, but manual testing is essential for catching business logic flaws, race conditions, and complex privilege escalation issues. Manual techniques often uncover up to 50% of vulnerabilities that automated tools simply miss. To secure your development, implement a CI/CD pipeline that shifts security left. Run secret scanning before committing, perform SAST and SCA on pull requests, and use DAST in staging environments. These gates help you catch issues before they reach production. Here is a view of the security tool landscape. From IDE plugins like SonarLint to container scanners like Trivy, deploying the right tool at the right stage, coding, building, testing, or operating, creates a comprehensive defense in-depth strategy. Secret scanning is vital because exposed API keys are exploited by bots in seconds. Use pre-commit hooks to catch secrets locally. If a secret is ever pushed to a repository, rotate it immediately and audit your access logs. Container security focuses on scanning base images for vulnerabilities and enforcing least privilege. Use minimal base images like Alpine, scan your containers with tools like Trivy or Gripe, and sign your images to prevent supply chain compromises. Infrastructure as code scanning ensures your cloud configurations are secure before deployment. Tools like Checkov, TFSEC, and Terrascan catch misconfigurations in Terraform and Kubernetes, preventing overly permissive security groups or unencrypted cloud storage. Bug bounty programs leverage the global community of ethical hackers to find vulnerabilities you might have missed. Platforms like HackerOne and BugCrowd provide a structured, responsible way to reward researchers for helping secure your application. Don't forget HTTP security headers. Implementing policies like Content Security Policy, HSTS, and X-Frame options provides an important layer of browser-enforced protection against common attacks like XSS, clickjacking, and protocol downgrade attempts. Finally, ensure robust TLS configurations. Stick to TLS 1.2 or 1.3. Use strong cipher suites and disable obsolete protocols. Regularly test your configuration with tools like the SSL Labs server test to maintain the highest security grade.